Okay, so once again, good morning, and we are going to learn about the basic concepts in differential equations. This is very important since we will be utilizing these terms, or you will be encountering these terms along the way while you solve for problems in differential equations. So the first thing is that you should be able to understand these terms and concepts in differential equation. So are you familiar with mathematical models, everyone? Yeah. So our first term here is differential equation. So what is a differential equation? So it's an equation containing derivatives of one or more unknown functions, or these unknown functions can be called as dependent variables, okay, with respect to one or more independent variables, okay? So that is a differential equation. Or to rephrase, a differential equation is an equation containing an unknown function and its derivatives. Yeah, to simply state that definition. Okay, so I have here some examples like dy over dx equal to cosine of x. This is a differential equation since it contains a derivative. Of course, the unknown function here is y, and the independent variable here is x. Okay. The next one is another differential equation, though here the derivative may be involved implicitly through the presence of, the differentials dx and dy. So this is also another way of writing a differential equation. Okay, may mga differentials lang. And the last one is another example of differential equation wherein you can see here partial derivatives. Okay, so these are partial derivatives. So it contains the unknown function here is v, and the independent variables here are x and y. Okay, so merong ordinary derivatives and merong partial derivatives. Okay, so there are two types of differential equations. The first one is ordinary differential equation, or we call this as ODE. Yeah, contains ordinary derivatives. So pwedeng of one or more unknown functions with respect to, okay, take note, a single independent variable. So it has only one independent variable. The next one is partial differential equation, or PDE. It contains partial derivatives of one or more unknown functions of two or more independent variables. Okay, so what are the differences? So for ODE, it has a single independent variable, and for PDE, two or more independent variables. So the question is, what is the independent variable? So how can we be able to identify independent variables or dependent variables in a differential equation? So earlier I have shown you naman the example of, a DE stating the dependent or the unknown function and the independent variable of that particular equation. So to give you further examples here of an ODE, so this first example here, so dy over dx plus y over x equals x squared. This is an ordinary differential equation since it contains an ODE. And what is that ODE? Contains an ordinary derivative, sorry. So the ordinary derivative here is dy over dx. Okay? So take note, dy over dx. So naka-fraction siya, di ba? Yung dy nasa numerator, the dx is in denominator. So the variable involved in the numerator part is y. So that is the dependent variable or the unknown function. And the variable involved in the denominator is x. So we call that as the independent variable. Okay, so that's basically how you can be able um, to be familiar with the dependent and independent variables. Okay, so ordinary derivatives. Okay, another example is it will not be limited to only one unknown function. The only restriction here is for this equation to be called an ordinary differential equation, it should contain a single or one independent variable. So just like this, one independent variable. Since isa lang naman eh, one derivative lang yung makikita. For the next example here, so dx over dt plus dy over dt is equals 2x plus y. As you can see, it has one independent variable, and that independent variable is t, the variable t. And the unknown functions here, since you can see dx over dt and the other term dy over dt. So the dependent variables here are x and y. So, but most of the time we'll be using an ODE with one unknown function and one independent variable. Okay, any question? None so far? Okay, so let's go to the partial differential equation. Okay, so partial differential equation or PDE, it contains partial derivatives. Okay, so yun yung first na idea. For it to be called as PDE, it should contain partial derivatives. So what's the idea? What's the property or characteristic of a partial differential equation? It should contain two or more independent variables. It means that the unknown function or dependent variable depends on two or more independent variables. For example, so this is an example of a PDE where you have the unknown function or dependent variable v, okay, and we have the independent variables, yung nasa baba, yung nasa denominator, yun yung titignan natin to check the independent variables. So you have x and y. These are independent variables. So this DE is a partial DE since it depends on two or more independent variables. So it's not limited only to one unknown function. So in this case, isa lang naman eh, one dependent variable and two independent variables. The next example will be showing you two unknown functions or two dependent variables, u and v, and the independent variables x and y. Okay, so the first thing is, para masabi na PDE siya, it should contain partial derivatives, and second one, the unknown function should depend on two or more independent variables. Okay? Gets? Okay, but most of the time we'll be using or we'll be dealing with ordinary differential equations. Now we go to the notations. Okay, so we either use the Leibniz notation. Leibniz, example nito ay yung dy over dx. Yan, for second derivative, so we write in this format and in this notation, second derivative of y with respect to x, third derivative of y with respect to x. So these are Leibniz notation. So yun yung common na nakikita natin. The next one is the prime notation, wherein you can see y prime, y double prime, and so on, okay, to represent the derivative. Okay, so just like this. Okay, so what's the equivalent of y prime in Leibniz notation? So dy over dx in Leibniz is equal to y prime or y prime of x. They're just the same. Okay, dv over dt is equal to v prime of t. What is the dependent variable here? The dependent variable in dv over dt is v. Okay, and the independent variable is t. Tandaan niyo ha, yung dependent or unknown function, they are just the same. Okay, that's the other way of stating or saying the dependent variable, and that is a known function. The last example, here we have the second derivative of y with respect to x. Y is the dependent or unknown function, and x is the independent variable. Okay, equal to y double prime of x. Or simply, you can write y double prime. Okay, so I have shown you this because you will encounter later some of these notations in the differential equations. So it could be written in Leibniz form or the prime notation. Clear? Okay, let's go to the classification by order and degree. Okay, so let's define first what is the order, or let's try to understand how can we be able to identify the order of a differential equation. So the order of a DE or an ODE, I have put here ODE since we will be utilizing for the entire class ordinary differential equations. I mean, we'll be dealing with ordinary derivatives. Okay, so is the order of the highest derivative appearing anywhere in the equation. So what does it mean by this? So we need to understand, or we need to be able to identify the order because um, later on, diba, we will be, deciding on what method or is appropriate in solving that differential equation. So you need to understand, order and degree. So basically order lang. Kahit order lang, okay na yun. And then the degree of an ODE refers to the algebraic degree or exponents of the highest order derivative after clearing off all the fractional exponents in derivatives. Okay? So any question here? Nagets na ba? Siyempre hindi pa kasi kailangan ng example. Okay, just like this. So I have said in the previous slide that the order of a DE is the order of the highest derivative appearing in the equation. So in this first example, y double prime of x. So y double prime means second derivative. Yeah, plus y prime of x raised to the power of 2. And y prime is first derivative, right? Equal to x. Now the question is, what is the order of this differential equation? So to find for the order, you have to check or to examine the equation. What is the highest derivative present in the equation? You have first derivative and you have second derivative. Of course, the highest derivative in the equation is second derivative. Since the highest derivative is second derivative, then we can say that this is a second order differential equation. Okay? Understood? Okay, now, how about for the degree? Okay, so we are looking at the highest order derivative, the exponent of the highest order derivatives. Looking at this equation, the exponent of the highest derivative, which is the second derivative, is 1. That's why the degree of the DE is first degree. Okay, not second degree because the power 2 here is the exponent of the first derivative. Gets? Okay, because first derivative is not the highest derivative in the equation. Okay, so you are to look at, the exponent of the highest derivative. Okay, so laging partner yan. Second order, what's the exponent of the highest derivative? 1. So first degree siya. Okay, now looking at the next example here, third derivative of y with respect to x raised to the power of 2 equals dy over dx, or the first derivative of y raised to 5. So what is the highest derivative in the equation? Highest derivative is third derivative. So the equation is a third order differential equation, or third order ODE, because the highest derivative, as you can see, is third derivative. Now, the question is, what is the degree of the differential equation? So you should look at the highest derivative. Okay, so don't look at the highest exponent in the equation. So just look at the highest derivative first, and then take note of the exponent of the highest derivative. And that way you can be able to determine the degree of a DE. Since the exponent of the highest derivative is 2, then we can say that the degree of a DE is second degree. Okay? Understood? Questions? Clear? Okay, you can unmute your microphone if you have questions, or you can raise your hand. Okay, anyway. So another thing here is for us to be able to determine the degree, if there are in any case or for some instance that you will see fractional exponents or radicals. So you must be able to clear off the fractional exponents. So make it a whole number exponent, okay? For you to be able to answer the degree of that differential equation. But the order, it doesn't really change. Okay, so whichever is the highest derivative in the equation, so that will determine the order of ADE. For this example here, number 3, y double prime, since ito lang naman yung nag-iisang derivative, y double prime, so automatically you can say it's second order differential equation. Then the question is, what is the degree? You cannot say 1/2 degree because of this exponent. So again, you should be able to clear off fractional exponents. So how do we do this? How can we be able to remove or to simplify or to make this a whole number? So what we will do is we square both sides of the equation. So we square both sides to eliminate the fractional exponents. So canceling what? The 2. So we have y double prime, ito na yun, and x squared times y squared. So in this equation, you can see that there are no fractional exponents. Then you can decide now, or you can answer now the degree of this differential equation. Okay, and that is first degree. So what's the exponent of y double prime? 1, right? So the degree is first degree. Okay, understood? Questions? Clarifications? None? Okay, so let me just clear this. Okay, if you have no questions, we can move on to the next page or next slide. Okay, so we're clear with the order and degree. So I think you can do this. So please answer this. Give the order and degree of square root of y prime equals 3 times y double prime raised to 1/3. Okay, very quickly, just give me the order and degree of this differential equation. Given problem natin, we are to identify the order and degree, right? Diba? So tama naman yung sagot nila. Second order, second degree. The given is y prime, right? Hello? Can you hear me, guys? Hello? Can you hear me? So 3y double prime raised to 1/3. Tama ba? So ito yung problem natin.
Yes, sir.
Okay, so to determine the order, you should look at the highest derivative. Y prime is first derivative, y double prime is second derivative. So ano yung mataas? Siyempre, second derivative is the highest derivative. Then, the order is what? Second order, or order 2. Now, since there is a radical sign here, a radical symbol, and fractional exponents, so we should eliminate what? Ano yung radical na to? Radical means y raised to y prime raised to 1/2. Okay? So y double prime raised to 1/3. So we will make the exponents, diba, whole numbers. So how can we do that? Yung least common nila. So you But you raise both sides to the equation 6, right? Okay, 6. Why 6? Yung least common, di ba? So 6 divided by 2 is 3. So y prime raised to 3. And here, 3 raised to 6. So we have, copyhin mo lang yan, 3 raised to 6, constant lang naman. So y double prime, yan, raised to 1/3 times 6, or 6 divided by 3, that is 2. So as you can see, the highest derivative here, na second derivative, yung exponent niya is 2. Therefore, the degree is 2. Okay? Or you can say second order, second degree. Okay? Any questions? Okay, so that's it. Okay, na-gets nyo na guys? I hope so. So that's it. So you have to clear all fractional exponents first before you can determine the degree of a DE. So walang problema dun sa order. Basta whichever is the highest derivative, kung ano yung highest derivative sa equation, yun na yung order ng DE. So if you can see fifth derivative there, okay, ibig sabihin yun yung pinakamataas na derivative, the order is fifth order. But in our lesson, so this prelim period, we'll be dealing with first order differential equations. So ibig sabihin, you will not see second derivatives in the equation. So first topic lang, since you will be arriving at a differential equation. So maybe you will encounter higher derivatives, like third derivative or fourth derivative in the equation. Okay, so clear tayo doon. Any more questions? None? Now let's go to the next part, and that is, okay, the linearity. Okay, so you need to know the linearity of a differential equation, whether the equation is linear or non-linear. Okay. So an nth order DE in the unknown or dependent variable y is said to be linear if it fits the form. So this is the nth order linear differential equation. Ito yung format niya. So you have the nth derivative. So ganun yung format natin. A sub n, so these are coefficients na function ni x or function of x. So y is the dependent variable and x is the independent variable in this case. Okay, so how can we make sure that we are, telling, we are stating the fact here that the equation is linear or not. So may dalawang properties tayo. The first property is the dependent variable y and all its derivatives. Take note, so take a look at the y here, since y is the dependent variable, and its derivatives. Okay, so this will be y prime, and this will be y n minus 1 prime, and this is y raised to n prime. Okay, kung naka-prime notation tayo. Nth. Okay, now it should be, the power should be 1. Okay, the power of the variable y and its derivatives is 1. Nakuha niyo ba? Yung power niya is 1. Kasi nga, other than that, hindi na linear yon. Pag linear, di ba, ano yung equation ng line? Y is equal to mx plus b. Oh, anong power ni y? 1. Anong power ni x? 1. So, di ba, linear yon. Line. Okay, but in this case, for our differential equation, so since we are dealing with the unknown function y or dependent variable, so it should be, yung exponent niyan or power is 1. If you can see here, y squared, it will not be linear. Okay, non-linear na siya. Pag may nakita ka dito na e raised to y, sine of y, cosine of y, okay, ln of y, that is nonlinear. Okay, we're talking about the unknown function. Okay, another property is the coefficients. So ito, functions of x yan. So whether may trigo functions ka man diyang makita, like cosine of x, e raised to x. So it doesn't matter dun sa mismong linearity. Okay, kasi nga function of x naman siya. Our dependent variable is the unknown function depends on the variable x here. So known kumbaga yung ating independent variable x. So otherwise, it's nonlinear. Okay? So to further give you an illustration, so let me first define nonlinear. So nonlinear ODE is simply not linear. Okay? If you can see. Okay, take note that dependent variable y, pag nakita mo to, in this case, na sine of y, okay, tindaan niya, dependent variable is y and that you can see expressions like sine of y e raised to y, then the equation is nonlinear. Okay? Kasi sine of y, hindi naman siya, ano ba yung itsura ng sine of y? Sinusoidal. Pag ganun, ano yung exponential? Okay? Curve. Do you follow? Everyone? Yun yung linearity ng DE. Okay, let's give some examples here. Number one, this is linear. Okay? Second order. Okay? Kapag we are finding for the linearity, so usually yung degree is 1. Okay? Pag linear, automatic ha? Pag linear, ang degree ay first degree. Follow? Kasi pag second degree yan, you will not be, saying it's linear. Non-linear na kaagad yun. Sa first property, remember, the derivatives and the dependent variable, the power should be 1. Okay, just like this. Okay, y double prime. Okay, sorry about that. Y double prime minus xy double prime plus 3y prime equal to x. The coefficients naman, so x, linear din naman to. Ayan, wala naman. Anyway, hindi naman nagmamatter. Doon tayo sa dependent variable na y. Y double prime, the power is 1. Y prime, the power is 1. Okay, so no other violations here. So this is linear second order. Okay, again, wala namang degree dito. I mean, pag degree, pinag-uusapan dito. First degree for linear ODEs. Okay, now let's go to the next example. Y prime plus sine of y equal to 0. So this is non-linear. Why non-linear? Because the dependent variable y, may involved na function dito na trigonometric function and sine y is not linear. Okay, that's why this is non-linear. The next example is y triple prime plus 3y prime plus 2y equals x squared is linear. Why linear? Sir, may x squared naman eh. So, x squared actually kapag pinag-usapan yung linearity is not actually linear, but we're talking about the dependent variable y here. So, doon tayo mag-focus sa dependent variable na y. Ano yung power na involved? Dapat 1 lang. So, y is of exponent 1, y prime exponent 1, y triple prime exponent 1. That's why it is linear. Okay? Linear equation. Next is y double prime plus 4y prime plus 2y equals e raised to y. Again, merong exponential function, but you have to make sure that yung involved na variables sa exponential functions na yan is not of the dependent variable. But in this case, e raised to y, dependent variable yung involved eh. That's why non-linear siya. Okay? Pero kapag sinabi natin, okay, when I say e raised to x, the question is it linear or non-linear? Anybody? So if that is
Linear, sir.
linear, right? Kasi hindi naman dependent variable yung involved dun sa exponential function, kundi dun sa independent variable siya. Okay? Sino yun? Who are you?
Sir.
What's your name?
Sandro Cardoso po.
Okay, Zandro. Okay. Good, Sandro. Now, next example natin. You answer this, guys. Is this linear or non-linear? Sine of x times y triple prime minus cosine of x times y prime equal to 2. Is this linear or non-linear? At kapag linear ito, what is the order?
Linear, sir.
Linear, sir.
Okay, linear. What's the order?
Third.
Third order,
Third.
Okay, very good. This is linear third order. Very good. Although may nakita ka dito na trigo function, sine of x and cosine of x, yung functions naman na to is not with the dependent variable or the unknown function. Nagets? Pero kung ito ay sine of y and cosine of y, not linear siya. Nakuha? So, check lagi yung coefficients. If it involves the dependent variable, then you have to decide and you have to make sure it does not violate the properties for linearity. Okay? Clear na tayo sa linearity? Okay, I think clear na. Because you will be having a problem set. You can answer that. You can start answering later maybe. But the deadline will not be immediately. So basta before the prelim exam, you should be able to submit the problem set. But I think you cannot proceed to the next activity if you can't finish the first one. So habang fresh pa sa inyo while the topic is fresh, so you should be able to answer the problem set. Anyway, at your convenient time, okay? Now we move on to the solution of an ODE. Okay, since the most of the topics here are focused on solving differential equations, so you must be able to understand the types of solutions. Okay, and these are okay. First, let's define the solution. So a solution of an ODE or ordinary differential equation is a relation connecting independent and dependent variables, okay, which satisfies the differential equation. For example, okay, this is found also in your module. So this PowerPoint or PDF will be posted in your MRooms naman, okay? Or you can see that in your module. So maybe you can access now your MRooms. You can see there a file of the module. Have you seen it? Maybe. Okay, so after this class, you check your MRooms. Okay, you make sure na may naka-upload doon na file. And the recording will be uploaded later, siguro. Okay, basta within the day, I'll be uploading this video recording. So the equation y equal to c e raised to 2x, this is a solution, okay? A solution of a differential equation y prime equal to 2y. Okay, let me just explain this. Okay, so how did we arrive to this differential equation? So in here, you have the variable c. This c represents the arbitrary constant. Okay, take note of arbitrary constant. It could represent any value, basta constant siya. So for us to arrive at its differential equation, to satisfy lang yung DE niya, we will differentiate, okay, this solution. Okay, since, ayan, if we differentiate this, ayan, both sides of the equation differentiate, differentiate y. Okay, first derivative of y is y prime with respect to x. Okay, take note the unknown function is y and the independent variable is x. Okay, now differentiating this with respect to x, you copy the constant c, you differentiate e raised to 2x, and that is e raised to 2x, derivative ni 2x, 2 dx. So 2 dx over dx, makancel na yung dx. So we have this first derivative of the both sides of the equation. Now, this is a differential equation kasi may presence na ng derivative. However, if there are still arbitrary constants, you cannot, conclude na yan na yung final answer mo for the DE. Okay, on how to arrive the DE. So you should eliminate the arbitrary constant. Gets? You should eliminate the arbitrary constant. So how do we do this? First is, diba, you should refer to the given solution, y equal to c e raised to 2x. Now, dividing both sides by 2 will make this, ito na, y prime over 2 this will be, makancel na yung 2 dito. So c e raised to 2x. Okay, and as you notice, c e raised to 2x is equivalent to y, right? So you now replace this by y. Then, wala nang arbitrary constant, di ba? We were able to eliminate the arbitrary constant. Means that, yun na yung ating differential equation. So having, eliminated the arbitrary constant or this part of the function gives us y prime over 2 equal to y. Ano yung y? This c e raised to 2x. Now, multiplying both sides by 2 will give us y prime equal to 2y. So this is now your solution of this. This is the differential equation of the given solution. Now, y equal to c e raised to 2x. Okay, clear? So that's it. Differential equation, ito yung kanyang solution. Ito yung solution kung saan yung DE niya is y prime equal to 2y. Now, this is actually called general solution based on sa types ng solutions. So ito yung dalawang types, general solution and the particular solution. Anyway, may question doon sa previous slide? None? Okay. General solution, yun yung unang kaagad na masosolve natin. Di ba? Once we are dealing with differential equations, the first solution that we obtain is the general solution. Kasi yun yung may presence ng arbitrary constant c. Okay? Sabi nga dito, di ba? Containing arbitrary constants. Okay? A solution containing the number of arbitrary constants equal to the order of the DE. For example, sige, magbigay ako. Second order differential equation. Okay, imagine this. So the question is, ilan yung arbitrary constants na makikita ko dun sa DE? How many arbitrary constants will I be seeing in that solution if the given DE is second order DE? Anyone? If you understand the question. Anybody? How many arbitrary constants will I be seeing or can I see or yung makikita ko dun sa solution ko kapag second order yung DE? There are two arbitrary constants, right? Sabi nga dito, di ba? A solution containing the number of arbitrary constants equal to the order of the DE. So if it's second order, you will be seeing two arbitrary constants. If it's first order, you will be seeing one arbitrary constant. Gets? Hello?
Yes, sir.
Okay, if it's third order, three arbitrary constants. Okay, ganun yung general solution. Now, for particular solution, this is a solution obtained from the general solution. So, for you to be able to determine particular, so dapat meron ka munang general solution. Kasi gagamitin mo you'll be using general solution to get the particular solution. Okay, so paano? You will have a condition or initial conditions. You will use that initial condition to determine the particular solution. You plug in the values of x and y or yung mga variables na yun dun sa general solution. And finally, finding for the value of the arbitrary constant c and then plug in the value of arbitrary constant c to sa general solution to make it a particular solution. Okay? Any question? So yun yung dalawang types ng solutions. To give an example, we have this one. Determine the particular solution of the given ODE x dx plus y dy equal to 0. So I should not be solving this. Ang dapat ipakita ko lang sa inyo is paano nakuha yung particular solution. Well, anyway, so we'll be dealing with the first order DE naman soon. So, okay, I'll be showing you the solution to that. Okay, ang given is you have a differential equation na x dx, right? Plus y dy. Okay, equal to 0. Okay, so pure function of x naman ito, pure function of y. You have a condition pala, guys. The condition is when x is equal to 0, y is equal to 2. Okay? If you have no initial conditions, ibig sabihin, ang makukuha mo lang is the general solution. Okay? Since, di ba, you're asked to solve for the particular solution or to determine the particular solution, you must be able to see some conditions in the given problem. Pag wala, ibig sabihin, the problem is wrong. Okay? May typo error siguro. Now, to solve the solution, again, this is a differential equation and we are solving for the solution. Okay? We first arrive at its general solution and then we determine the particular solution applying these conditions. So we integrate both sides of the, integrate each term. So we give us integral of x dx, remember? X squared over 2, right? Plus integral of y dy, that is y squared over 2. Do you remember this? Everybody? Equal to arbitrary constant c. Okay, again, so I said arbitrary constant could represent it by any value. We can use this to simplify. We can actually modify this to simplify the given equation. Okay, since common yung mga, di ba, yung c na yan could represent any value. Pwedeng 2c, pwedeng c over 2, e raised to c. Again, we can rewrite, di ba, para ma-simplify natin yung equation. But in this case, we will be modifying the c, divide by 2. Kasi common sa kanila, di ba, yung over 2. To simplify lang, to further na hindi mo na kailangan pang palitan yung pinaka-final answer. So, in here pa lang, pwede mo na siyang i-modify. Okay? This should be the general solution. Okay? Pero pwede pang i-simplify. Paano, sir? Okay? By making this c over 2, so multiply both sides by 2, will eliminate the denominator, magiging x squared, okay, plus what? Y squared equal to c over 2 times 2, c na lang, di ba? Okay, ito na yung general solution. Okay, general solution. Okay, baka may tanong sa inyo dyan, di ba? Sir, paano kapag hindi ko nilagyan ng over 2? Ang magiging sagot dyan kapag walang over 2 is to eliminate the denominator here is magiging 2c siya, right? Okay, sabi ko nga yung 2c could be put into what? Pwede mong sabihin na arbitrary constant c pa rin naman siya. But in here, ang ginawa na lang natin is we simplified by modifying the arbitrary constant. But anyway, I'll discuss further itong ganitong part na to. But our main concern here is to determine the particular solution. Okay, this is the general solution. So, how can we be able to arrive at its particular solution? Ibig sabihin, pag meron ng value yung c, if c has a value, then that is the particular solution. You just write the entire equation and then put the value of c. That's the particular solution. So, we have conditions to determine that c. Okay, you apply x equal to 0 and y equal to 2 in this general solution. So, apply natin. So, 0 squared is 0 plus 2 squared is 4 equal to, ayan, c. Ibig sabihin, ayan, c is equal to 4. Again, this is not the final answer since this is just a value of c. You plug in here, this is a general solution yung value ni c, so you have the particular solution. So, x squared plus y squared equal to 4. This is now the particular solution. Okay? Nagets? Hello, people of the Philippines versus Sir Phyl. Okay na tayo sa general solution. This is general solution and this is the particular solution. Okay? Hey, nagets na yung dalawang types ng solutions?
Sir.
Okay, basta ganun yung idea. So, pag general solution, yung C could be any value yan. And every value or each value of the arbitrary constant represent one particular solution or one solution, just like this. Are you familiar with this equation? Circle yan, right? It means kapag graph natin yan, that circle is, sige, sulat natin. Yun yan. Equation ng circle yan na yung center ay nasa origin, right? And the radius here is 2, right? 2 squared is 4. Kaya 2 yung radius niya. So ayan na. This graph here represents this solution na x squared plus y squared equal to 4. Do you follow? Yes. No response means okay, na-gets? Okay, any questions, guys? Okay, kung walang tanong, clear na ba? Everyone? Sir, late po kasi ako nakapasok. May tanong dito. Nakita niyo ba yung tanong sa chat? Ano pinagkaiba ng partial sa ordinary differential? Tsaka if ever po, laging y po ang dependent variable. Okay. For standard notation, sa mga standard na equation pala, y prime means dy over dx, di ba? So, laging yung y is dependent variable. Pero may mga instances naman na hindi lagi na y yung dependent variable. Lalo na kapag hindi naman involve yung y, di ba, as one of the variables in your equation. For instance, ds over dt. Okay, sige. ds over dt, what's the dependent variable there? S, di ba? Okay. Ano yung independent variable mo? T. Ano pang mga example? dr over dt. Ano yung dependent variable? R. So, sa standard notation lang din talaga kapag involve yung y and x na variables. So, laging, unless specified na yung x yung dependent, yeah, baligtad. But yung ating standard nga, y is always the dependent variable. Okay? Kapag yung involved na variables ay y and x. Nakuha? Nasa numerator mo, dy, denominator is dx. Clear na ba, Mr. McKinley? Tapos, if ever, ano yung pinagkaiba ng partial at ordinary? Yung partial na DE is, ano yung involved doon? Partial derivatives. Okay? And yung partial derivatives, it depends on two or more independent variables. So, hindi lang x yung independent variable doon. May x, may y. So, depende kung ano yung nakalagay doon sa equation. And ordinary DE naman is involve yung ordinary derivatives. Ano yung mga ordinary derivatives? dy over dx, second derivative of y with respect to x, as in ano siya, total differential. Okay, hindi partial. Gets? Gets na, McKinley? Okay. Next is, may tanong dito, sir, sa y po ba parati magbe-base kung linear po or non-linear? Yes, nakadefine naman doon, di ba? Linear in terms of y, the dependent variable. Okay? Basta kung ano yung dependent variable. Okay? Not necessarily na y, basta kung ano yung nakaalagay na unknown function or dependent variable. But in our example, y is the dependent variable. Kaya doon tayo magbe-base. Okay, Manuel? Clear? So yun lang. That's all. So I hope you have learned something today. Our next topic will be elimination of arbitrary constants. Okay, the objective of this topic is how to arrive at a differential equation. Okay? So maybe I'll discuss this sa next meeting para sabay-sabay kayo. Ayan. Or I'll be posting some video about the elimination of arbitrary constants. But for sure, I'll be discussing this next meeting, okay? That is next week. Elimination of arbitrary constants. Or for clarifications. Maybe I'll be posting a video and then next meeting, I'll be answering your questions if you have clarifications about, the video presentation. Okay, everyone. So, pwede na kayong unmute ng microphones and then show your faces for our final for our group photo. So, stop the share and I'll stop the recording.